thing. So the shape is very less. It is a small data sets only. You have to be very careful. These are the very large number of the features, but the observations are very less. And these are the different columns which we have. We didn't see in these columns here, but here also we are not able to see, but these are the just sample columns which we have. Like in terms of sports wise, like, so there are so many columns which we may not be know exactly what they are. And in terms of info, if you type the info function also, you will get summary of the what exactly the data is. And this is also give some kind of the observations, like it going to be win or loss, and some of the games they have played, and some of the observations along with the column names. So this is just a brief idea about the data and some kind of relations between those things. So yeah. So if you want to perform the data types of the each column, you can directly use the df.t types. So it's all almost like numerical variables. So some of the variables, I can say some of the variables may not be numeric. So we want to convert it to the numeric. So that's why we got observation for a win, which we had something called categorical variable, which we were going to be do some kind of numerical wise. So that's why we are applying to convert the numeric way. So correlation. So what is exact meaning of the correlation? When we are going with some kind of bivariate analysis, so by using feature to feature interaction, we have to come up with some kind of the observations or some kind of analysis over it, whether the distribution is similar to that or not, and also how much correlation between the two variables and two features. So what is the exact difference between them, and how does they correlate it? If suppose the two features are correlated very high, or I can say more than the 0.5 results, we have to ignore that point, because whenever you encounter some of the large, I can say large kind of variability or large kind of correlation, that model won't be works well, because it needs to support with the Gaussian distribution, right? So whenever you have the mean with similar kind of variability or features, that will going to be help us. If it is a skewed feature, how does it going to be help us? It may not, right? So that's why we are ignoring the points of high correlationality. So here also we are doing something called as a whatever the variable which we have in terms of 0.5 result, we are going to be ignore it. We are going to be filter it, I can say. We are going to be ignore it. We have to extract that one. So we are just checking the win future, how does is the correlated with it. And also we also plot this one heap map, which we call it as, we get to know about the relations between the what exactly we have features in the data set. So just to type like a heap map and whatever the data set we have, and the correlation function. This is a correlation function, and this is just operations to get to know about this heap map, like a whatever the width you want and the color, some annotations if required. And this is just figure size, how much the figure size you want. So by using this matrix or this heap map, how do you know which feature having the high correlation between the variable. So by using this, you will observe quickly, this is the diagonal, right? So diagonal, it's obviously going to give as a 1. So whenever you encounter something, so here you can find something coloring, right? So dark blue is a high collinearity, and this yellow or white, this is going to be very low collinearity. So I hope you see this diagonal, right? So this diagonal, which always going to be high collinearity, because it is interacting with the same variable only. Win is win, and off adds is off adds, x-axis and y-axis. So Whenever you encounter like zero point 0.9 or zero point 0.8, so let's say this example here, we are getting high collinearity with off ads and something called off ads play. So I think it might be some kind of meaning with off ads and off ads play. So that's why it is giving the high collinearity between those two features. And something called this one, you can see here, this is also somewhat very high collinearity between the off ads and I think off TDs. So we don't know what exactly this meaning of these features, but how does this going to be help us in the modeling purpose? We have to see it. Then we have to perform how does these features is going to be help us by using the something called feature importance and feature selection process. So similar way, we have to find it like this number you can see here, 0.99, which is very high collinearity between this of TDs and total TDs. So it might be something related to the terms, but we don't know exact meaning of these things. We have to ignore it. These high collinearity and I whatever the high dimensional I can say high collinearity between these two features, we have to ignore it. That means we may remove this feature or this feature. We don't know exactly. By using the feature importance and feature selection, which we are going to be selected, that's up to the mark of after model building. So for just now, we have to assume like this is a way to analyze it and this is a way to understand this heat map. So I think we have seen the pair plots, right? Yesterday also we have seen the something pair plots. Here we have large number of features, so that's why we are getting this much of pair plots. This is obviously going to give some kind of statistic way of analysis, whether these features consist of which distribution, whether it is a Gaussian or normal, and also the log normal or skewed. So something which is going to be help us by using this also, but here we are getting a lot of the columns, so that's why we may not be going that much of detail. This is going to be a fail, I can say, fail plotting technique. So the heat map is very good to understand and visually it's going to be give as a good results when compared to pair plots. I hope it's understand, right?